Hello, this is Susan Paz, and today I'd like to introduce you to complex numbers. There is something called an imaginary unit, and it's identified using a lowercase I. And what I is identified as, or defined to be, is I is equal to the square root of -1. So it's just a symbolic notation for the square root of -1. Because you'll remember in the set of real numbers, we didn't have a solution for this. So now we're moving on out into the set of complex numbers, and we're defining what the solution for the square root of -1 is going to be. So you'll need to memorize that. And the other thing that you'll need to know here is that I squared is defined to be equal to -1. So those are two important things that you're going to want to remember. So this is how we're going to use it. We're going to be taking the square root of negative values, and what we're going to do is split it into a positive number, square root of a positive number, and the square root of -1. And of course, as soon as you see that square root of -1, you're going to go back up here to your definition for the square root of -1, and you're going to replace that with a lowercase I. Notice that that lowercase I is not up underneath this radical sign. So generally, you will see it written in this form with the I in front of the radical sign, and then the radical notation coming second or last in the expression. So let me do a couple of examples with you. In the first one, we're going to take the square root of -25 and we're going to write it using I notation. So this is the way I would like you to think about it. You're going to split it into the square root of +25 multiplied by the square root of -1. So you can still see that underneath the radical we still have the -25. We just separated it into two expressions. So now doing the work, the square root of 25 is 5 and the square root of -1 is I. So your answer there is 5I. Same thing over here with the square root of -225. I'm going to split that up into the square root of +225 multiplied by the square root of -1. And of course, when I do these operations, taking the square root of 225, I get 15. And by definition, the square root of -1, we're now defining that to be the letter I. So let me scroll down past some of these others. I wanted to refresh you on simplifying radicals. So I'm going to take a look at this square root of -32, and we're going to split this up into 16 times 2 times -1. So again, you'll see 16 times 2 is equal to 32, and then this -1 makes that product a -32 product. So the square root of 16 doing the work is 4. The square root of 2 is just the square root of 2. I cannot simplify that. And then the square root of -1 is defined to be I. So let's put it in the proper form. Let's put the 4 and the I first, and then let's let the radical part of the expression come last. So 4I times the square root of 2. And one more, when we work with -180, let's see, I think I'll do 9 times 20 times -1, and these are all square roots of, I didn't say that. And then I'm noticing that within this 20 there's another perfect square, so let me go ahead and break that apart before I actually start to do the work. All right, so here's 4 times 5 is 20, times 9 is 180, times -1 is -180. So now doing the square root process, the square root of 9 is 3, the square root of 4 is 2, the square root of 5 cannot be simplified, and the square root of -1 is defined to be I. So let's put it all together. 3 times 2 is 6. Let's pull the I in front, and let's put the radical in the last position. All right, so here we're now talking about complex numbers. We've defined I and we know how to work with it. A complex number is a number that can be written in the form A plus BI. where A and B are real numbers, and A is called the real part because it belongs to the set of real numbers, and B is called the imaginary part. Okay, so if the B part is 0, then we have A plus BI is equal to A plus 0 times I, and of course that just leaves us with A, which is going to be a real number. But if A is 0, then A plus BI becomes 0 plus BI, and that is an imaginary number. All right, so when you're working with complex numbers, you're going to always want to be writing them in the form A plus BI with the real number appearing first and the imaginary number appearing second. So let me show you how to take these complex numbers. Let's just look at some of these complex numbers down here and see what they look like. The second one over here, 4 minus 2i, is a very common simple version of a complex number, and we're asked here to identify the real part and the imaginary part. The real part of this is the 4, and the imaginary part of this, and you have to be careful with this, is just the -2. You don't want to include the letter I in that. So that one's relatively easy. 4 is the real part, -2 is the imaginary part. Let me show you on this first one over here, in order to get it separated into real and imaginary. This one, because it's fractional or rational, needs to be broken apart into the two pieces. And you can see the first part is the real part because there's no letter I in there, and the second part is the imaginary part. So I can do a little simplifying here. This -12 over 10 will simplify down to -6 over 5, and then you just have to leave the second part of that as it stands. You cannot go canceling in here. That's not a 6. It's the square root of 6. So if you want to identify the real part of this one, it is the -6/5. And the imaginary part, I'll just abbreviate that, is the square root of 6 over 10. And I want you to do one more. This one is, you notice that there's no real part to it, there's just an imaginary part to it. So it's okay to mentally or actually on paper write down that 0. So I can identify the real part is the 0 and the imaginary part is the negative square root of 3. Okay, I think that's a good place to stop for our introduction on complex numbers.